with that one. So you should have gotten an email from me with the presentation. You can click on the sign-in link there to sign in. If you didn't get it, one of your schoolmates can email it to you, or you can email me and I'll share it back with you. We'll make sure you get it so you can get signed in and all of that type of stuff. It's just a Google form to sign in for you there. So next one. So I'm starting with some FAQs because I want to get to the point where we're doing the good stuff. Where do I find the new standards? Put a link directly to the GSE website on the DOE website. What changes have been made? There's a crosswalk document that shows you side-by-side comparison of the standards. General statement, most of the content, the facts, figures, formulas, is the same. It's the student expectation that is different. Okay? But you can see the crosswalk there. What textbook will we use? There's not a textbook that currently supports the GSE, so we're going to work towards creating our own resources, borrowing those from others. Just as a general rule of thumb, if you see things that are next-gen science in GSS, labeled, you can use those, but you'll need to make sure that the topic that it's addressing aligns with with our standards. So it may say 5th grade NGSS, but that may actually be a 4th grade Georgia standard. Okay? Just make sure that the topics align. Okay? I've actually seen some of the middle school NGSS stuff that would work really well for 4th and 5th grade, just as I was looking at stuff. Where can I find support resources for implementing it? Well, will you click on the resources for 3D learning, please? Yeah, just let everybody read my email. That'd be great. Oh, even if you close it, it's still going to pop up. So I have this document, which you now have, because you can click on the link in the presentation and see it. A friend of mine from Troup County helped to put it together. I'm taking this document, adding things to it, which I've already done some of it, and I'm going to turn it into a website that will go on our curriculum webpage. For now, as you're working, you can go through here and see the links for all these different things that are in there available to help you implement the new science standards. One of the things that is the toughest to do, I think, is find the phenomenon that we're going to be talking about today. So if you'll click on the phenomenon link, scroll up. Right there. Classroom resources, and then phenomena. Keep going down. There you go. And then it's a bookmark, so it'll take you down to the bottom to the particular section of the Google Doc. And you can see here some of the phenomenon locations for finding phenomena to do your lessons with. If you want to go back to the top, there's that return to the menu button. And then click there. It's okay. And so you can see the resources that are available for you there. Okay? Go back. If you are concerned about assessment affecting your evaluation next year, it is hold harmless. So it will not be factored in because it is a rollout year. So 5th grade teachers, while your students will take it, and we will get data from them. It'll be much more lagging data. We won't see the results till much later because we'll have to go through the process of setting the cut scores. And that will happen in September. So we won't know how our students did until probably December of 18. So it'll be a bit. Okay? Because they'll take it in April of 18, April of next year, and it won't be until December that we see how they did. Okay, just so you know about that. If you want to get more training, on March 28th, that's 2 weeks from Tuesday, we will be here starting the process of working on our scope and sequences. And examining our SGAs and those kind of things to start developing those curriculum materials to support it. My goal is to have a scope and sequence, and with the units, that there are lesson plans that you can click on that will have all the rubrics and everything that will be ready to go. so that you'll have all of the activities, at least for the first semester, and then we can go back and reevaluate to see where we need to fill in as we're working through next year. Okay? But the goal is that you have at least enough to start in every grade level to get rolling with the GSE next year. Okay? That process will start on the 28th. I'll be doing more sessions. I'll stay away from you guys during milestones and all that kind of stuff. However, if you want me to come to your school and do some specific, you just want me to sit down with your second grade grade level, I'll be glad to do that. Okay? So all you got to do is ask. And I can come out and show you some things in just about 30 minutes. Okay? We'll be at RESA in June. Hopefully by that point we'll have frameworks to be able to work with. It's $15. That includes your lunch. And I bet you could get your principal to pay for that. Okay? Because it's only 15 bucks. And then on June 14th, we'll be here at WERS doing a full day of resource collection, maybe trying out some of the lessons, those kind of things, to see how they fit in order to get the scope and sequence ready to go. Okay? Hopefully, that day will be just finalizing stuff, because I hope that we can get a lot of it done before we get out for school. But I understand how the last couple of months go. So, but I'll send out more information about those meetings later. Next slide. So, you maybe saw the 3D glasses when you came in. You've maybe heard a little bit about 3D learning before. 3D learning refers to the three dimensions of science that we're focusing on. And if you look at that emblem there in the center, the blue is the practices. Those are the science and engineering practices. There's the content, which is the what we teach. And then there's the cross-cutting concepts. Those are, I hate to call them big ideas, because they're really more like bigger than big ideas. They'll go across pretty much everything. I even think they go into things like social studies and math and all of those kind of things. But strictly speaking, in science, we're going to focus on those things, what they think about. All of that centers on what we're calling authentic phenomenon and problems. So phenomenon can be anything. It can be like I was bringing my milk jug in here, and it was leaking. It had a hole in it. But when I closed the top, it quit leaking out the hole. That's a phenomenon. That's not crazy. That's not a black hole, although it could be. A black hole could be a phenomenon. Those are the kind of things that we want to start every lesson with. Something real. Here's why we're learning about this, because this really happens out in the real world. We're going to use all of these tools to help us make sense of those phenomena. That's what that black piece down there in the bottom says. That we want to use all of those tools in order to make sense of the world around us. It's all right? So if you look at the blue part, the what scientists and engineers do, that's correlated right now to our current standards. Those are the characteristics of science that you may or may not get to. You know, so like my middle school and high school folks, they do a week's worth of that stuff at the very beginning of the year, and then they never talk about it again and say that they've done it. The idea with the new standards, you're going to see in a second, is each standard has three pieces to it. It's got the practices, it's got the content, and it's got the cross-cutting concepts all wrapped up in there together. So in order to meet a standard, you can't just have them do this standalone vocabulary lesson and that be it. Vocabulary is very, very important, but that can't be all that we do with science because it doesn't meet the standards. Okay? One of the ones that I find really, really interesting to look at with this is analyzing and interpreting data. That's a science thing to do. How many of you guys have been analyzing data lately? So you guys are actually scientists or engineers. You're student engineers, you know, brain surgeons if you want. You're looking at, you're asking questions and defining problems of your students, right? Where are the issues? How can I help my students get better? You're developing models. You know, you guys got flex grouping, right? Differentiation, you know, the centers. You got all these different models that you're developing within your classroom. You're planning and carrying out investigations. Every time you do a lesson, right, that's an investigation. Let's see how this works. Analyzing, interpreting data, we talked about that. Mathematical and computational thinking. I bet some of you guys can do some pretty quick math in your head when it comes to some of the data that you're analyzing. Constructing explanations, you know, that's a parent-teacher conference, right? Engaging in argument, again, parent-teacher conference. And then the last part for me, which kind of sums all of this up, is obtaining and evaluating and communicating information. When scientists learn something new, they immediately share it with the rest of the world, and then the rest of the world says, okay, where's your evidence? Prove it. They communicate with each other, go back and forth, that they adjust. You know, some people get really, really mad that Pluto is not a planet anymore. Have you heard that they're talking about bringing it back into the fold? People get upset about that because you're messing with, you know, my posters and those kind of things, right? But that's science. That as new and better data comes along that helps us reclassify something, we do it. We don't just keep doing it the way that we've always done it. We gotta fix it. That's what people don't get about science. That's one of the things that we need to be able to work on here. Okay? When we look at the cross-cutting concepts, patterns, cause and effect, you know, those kind of things, I mean, do you see how those are really big ideas? Do you see how we use those across all kinds of disciplines? Right? Energy and matter, that works its way throughout just about everything. Structure and function. I mean, that's a political science concept, isn't it? You know, how we structure our government and the function of each of the branches. You see the connections there? All right. The thing that I hear a lot from elementary teachers is that you're being pushed to focus on math and literacy, and you don't have time to teach science and social studies. All right. I'm recording that. I know what's being said to you guys, whether directly or indirectly. I get it. Okay? And if I'm in your shoes, and my evaluation and my principal's evaluation is tied directly to those math and reading scores and writing scores, yeah, I don't blame you at all for wanting to let some of that other stuff slide. Okay? What I want to show you guys today is that the science standards are very literacy focused. They're very math focused. They can help you in achievement in those areas if you use the science as the context. You use the phenomenon to help you ground what you're doing. You know, I saw a Facebook meme talking about, you know, Carlos with his 600 cantaloupes. You know, and if so-and-so takes so many cantaloupes and blah, 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 and, you know, the kid says, well, why the hell does Carlos have 600 cantaloupes? Right? Because what's the kid saying to you? Who cares? Right? I get it. You guys right now are all looking at me like, yeah, who cares about this? I don't blame you. You guys are thinking about, you know, tonight is St. Patrick's Day. You know, where am I going to go and get my green beverage this evening? You know, I get it. Your kids are the same way. Right? You guys came with expectation for me to give you something. Or some of you came because you were made to come and you had zero expectation. I get that. That works too. My point is that the kids need a reason to learn what you're putting in front of them. Science. I know you don't have time to teach science every single day the way that I would want you to do it. All right? But science can help you achieve in other areas because it gives you the context. Okay? Next slide. So here's some of the standards. Here are the comparisons of them across grade bands. You see the difference. Look at your fourth grade physical science. Construct an argument to support a claim that gravitational force affects the motion of an object. Construct an argument. What is that going to look like in a fourth grade classroom? Is it going to be a bunch of kids yelling at each other? If you do it incorrectly, right? But don't we want adults to argue from evidence? You know? Don't you wish that some people would actually pay attention to the actual evidence that's there, the actual data? Right? Plan and carry out, that's 6th grade, plan and carry out an investigation. The kids have to do it themselves. They may get the wrong answer. That's okay. Don't tell them the right answer. Tell them the wrong answer. Help them identify where it went wrong. Okay? That's the biggest thing that I see from like my middle and high school folks is they want to tell the kids the right answer. They can't let them go. You guys are much better about that, which is great. I love working with you guys. And then developing a model there, that's a high school biology standard. I'm not talking about building a model. I'm not talking about, I don't know how you would build a physical model to explain the role of natural selection. I don't know what that model would look like. I mean, maybe you could get steamy, you know, and make it steam and have them carve it out of, you know, marble or something. I don't know. We're not talking about building a model of the cell, although that is an option. What we're talking about is building a conceptual model. It could be a comic strip, right? Where they could look at natural selection and show, you know, different ways that natural selections happen. That's a model. The great thing is then you can say, let's look at the model and let's critique it. What are the flaws in it? What are the strengths of it? The one that I run to is the model of the solar system. You know, when I say solar system, what do you got? What instantly pops to your head? Yeah, styrofoam balls. The yellow one is the sun, right? And they're all like in rings and perfect circles all the way around it. Sometimes they're in a line. You know, you might have a poster with the sun over here, right? And then, you know, all the planets perfectly in a line. You know, and the Earth is this big and Jupiter is this big, right? Those are models. That has limitations. Having your kids discuss, is that the way that the solar system really looks? That's important. Critiquing someone else's model is important. Right? Next slide. So, what I want you to leave here knowing is that our standards are phenomenon-based. That's where we start. These are all phenomenon. My example of my leaking milk jug up there is a phenomenon. It can be a picture. The kids can put their hands on it. It can be a video. They just need some way to experience it. The picture there on the lower left, that's Providence Canyon, okay, which is a fantastic phenomenon. So many great things that we can. That's earth science. That's environmental science, life science, all that good stuff. Physical science wrapped up together. You know, but people see that and they say, well, that's earth science. Well, no, you could talk about chemical and physical changes there, couldn't you? All right? The guy floating in the Dead Sea over there, right? I don't know about you guys, but when I try to float and read the newspaper, I tend to drown. And the kid with the hair sticking up. I mean, that's something that you guys may experience on your own playground, right? Those are phenomenon, and they're observable events that we use our science knowledge to explain. The idea is that you have maybe a big, really engaging phenomenon to start, and then you have smaller phenomenon that the kids can actually explore. So if we're studying in middle school and high school, we study pressure, air pressure. The tanker car crush, you guys ever seen that before? It's a train tanker car, and then it implodes. You know, obviously you can't bring the train tanker car into your classroom and implode it, but you can use a soda can. And then you could take it one step further and put some marshmallows inside of a syringe and pull the syringe out, and you lower the pressure in there and the marshmallow expands. You know, and then you squish the syringe in and the marshmallow squishes. Those are phenomena that you can observe in the classroom that are connected to my big guiding question. Next one. Oh, wait. Did we skip one? I think there was one. There it is. This one, my life science teachers love this one. And I've had several of our high school biology teachers teaching this particular lesson, and the kids love it. The guy that you see there, he's from Douglas County High School. He died when his football coach told him that he needed to drink more fluids. So he went home and drank 2 gallons of Gatorade and 2 gallons of water over the course of 2 hours. And he died of water intoxication, swelling of the brain. All right? It doesn't get any more engaging for middle and high school kids than talking about what other kids are doing. Right? So we took that, and we put some potatoes in some salt water and some sugar water, some regular water, and then we looked at the pieces of potato. Because obviously we don't want kids experimenting with water intoxication. Now, they did go out and they did some research on water intoxication and found all the different kinds of ways that it happens. Either you have a condition or something along those lines, or you did something to yourself, like chemically taking ecstasy makes you really, really hot, and you drink a whole lot of water, and people die from taking ecstasy because of water intoxication, because they just drink. There was it was like a radio giveaway thing where if you were able to drink so much, what was it?
Radio station, it's like you had to try to drink 2 gallons of water and fastest, and that woman.
She died. Yeah. So I mean, it's that kind of stuff. You guys have seen maybe on YouTube the guy trying to drink a gallon of milk. Yeah, and and then the last slide over there is, those are cheek cells in different solutions to see, how they shrink and grow and all that kind of stuff. But the idea is that you've got this really engaging phenomenon to start with. You've got these smaller phenomenon that the kids can explore that are tied back to that original phenomenon. Okay? So, next slide. So, when we're thinking about science at the elementary level, the literacy piece keeps jumping back to me, and that's practice 8, science and engineering practice 8, obtaining, evaluating, and communicating information. I just read an article that was talking about forget coding. You guys have heard, that we need the kids to learn how to code. What they're saying now is that we're getting kids who can code, but they can't write. And you have to be able to communicate with your coding. And it was a really interesting article. I got to go back and finish it. I was reading it while I was cramming Subway. But it's really interesting how that writing and communicating like that has become an issue. What we want to focus on is we want the kids to be able to communicate the information to you that they have learned. Because once you've figured out what they're thinking, then you can help direct them. You can see where their misconceptions are. You can see where they need a little course adjustment to get them back on track for their learning. And the question is, how do we make students' thinking visible? Well, you guys know. You've already been doing this. You've been having them write for you, right? And explain things. Sometimes you have conversations with them in a classroom. And those are incredibly valuable opportunities for you to sit down and talk with them about what they know. Will you go to the next slide? So one of the things that I love is the series of books called Uncovering Student Ideas in Science. And they're formative assessment, little probes. They all start with a phenomenon, a scenario. They give you student perspectives of that scenario. And then they ask you, which one do you agree with and why? If you go to that slide in the presentation, you can click on it. Will you click on it for me? And there's my email. So I took that probe and I put it into a Google form. Put your name in there. I want you guys to do it. Put your name in there. Put your teacher. And then put your response. and then why you think what you think. 3 to 5 sentences, paragraph. This is informal, so I'm not going to give you a real hard time about your grammar. I want to know your thoughts. But I will ask you what you're thinking. Will you scroll back up so that they can see the actual scenario? Yeah, scroll back down there. There you go. So Preston says, I think we should have a small pulley. That way we won't have to pull as hard. Sarah says, I disagree. I think if we use a big pulley, it would be easier to lift the wood. All right. Notice you're also modeling the conversation for them. You know, saying, I disagree. Showing them how to respectfully disagree and communicate their findings. And then Aaliyah says, I don't think it matters what size pulley we use. We would have to pull the same. So, Judy, if you'll click on the pulley size tab at the top. Oh, that's right, you can't see.
No, yeah. This is
To the left. Keep going to the left.
Oh, okay.
So it dumps it out into this spreadsheet for you. Now we can start talking about who thinks what. I don't know that I would throw it up on the big screen, because you never know what they're going to type in there. Somebody's going to type in "see more butts" or something like that. But let's look. One of the responses is Joe Bob, and Joe Bob, who is Dr. Barnes' student, says that Sarah is correct, and he says Sarah is correct because less effort, more distance. I'm going to ask Joe Bob, what did you mean about that? What does that mean? And we're going to have a conversation about it. I'm going to say, can anybody add to what Joe Bob said to make it more clear? Does anybody disagree with Joe Bob? You could take this and you could sort it by which friend. Then there's your groups. Because each one of the responses highlights a particular misconception related to the topic. And so then you can send that group to a particular center to get a particular experience. All right, turns out the correct answer is Aaliyah. All right, the pulley doesn't do anything except change the direction that you're pulling. Size of the pulley, doesn't matter. Okay? What I would suggest is that you don't do what I just did and give the answer, that you use this as your discussion point. You leave them hanging when it comes to this. And then you use this as your post assessment. When you do your post, you can go through, add another column into your spreadsheet and do some quick ratings. 1, 2, 3, 4. And then when you're sitting in the parent-teacher conference and they want to know what is it supposed to look like, well, here's little Johnny's response, and here's little Susie's response. Johnny's a 1, and here's where we need him to get to a 4. No, obviously don't show them that it's actually Susie's response, but you get the idea. Do you see how that makes it a whole lot easier than having a stack of these to go through? People say, oh, I don't like spreadsheets. I get that. All right. I don't like having a stack of papers that I have to sort through that, I spill coffee on and, all of that kind of stuff. I don't like having to sift through and figure them out. I can sort these by their responses, who got it right, who got it wrong, super easy. I'd have to pull them out, and put them in piles if I did it in paper. Okay? That little bit of time to learn how to do the basics of the spreadsheet will save you a whole lot of time later on. And then you can take it and apply it to all kinds of other stuff. Like when I went to Noonan Crossing to your science fair. I noticed you'd handwritten on each page, each score sheet. I wanted to take that and do a mail merge and put each student in there with a project in there so you didn't have to write it. That's a spreadsheet thing that we could do very, very quickly for you. And next year we'll set that up. So the kids register themselves, dump it into a spreadsheet, and then you just print it out. And that'll save you a whole lot of work. That's the kind of stuff that we can use the Google for. Okay? Next one. So what we want to do now is we want to split you guys up into groups and focus. Our K2, you guys are going to stay down here, and y'all are going to work on cranberry bogs, which is a phenomenon that's really interesting. And then upstairs, we're going to do 3-5. We're going to do some chemical and physical changes. Or wait, which one are we doing? Physical science. Yes. So 3-5, go with Lisa. Take your Chromebooks with you. You can leave everything else here. And then K2, stay here with Judy. Those of you that are instructional coaches, go wherever you want to go.